Your nonlinear inequalities, not only do you graph the associated equation, you also do some shading. So I'll draw that down. You don't need to go as far as a 9 by 9 in all directions. A 5 by 5 should be sufficient. So the first one we'll do in purple here. We're going to ignore the inequality for now, and we're going to graph the associated equation, x squared plus y squared equals 9. What does x squared plus y squared equals 9 look like? Of radius? And where is it centered? At the origin. So that means if you were at the origin and you moved up, down, left, right 3 units, you'd be getting graph points on your circle. So this is pretty much what we did in 1.1. Now, as far as connecting these dots, since we have a non-strict inequality, am I going to use a solid line or a dotted line? So if you want steps, the first step would be to draw the associated line, or curve in this case. The second step would be to pick a test point. It doesn't matter what point you pick as long as it's clearly not on your curve. So give me a point that's clearly not on this curve. You can pick a point that's inside the circle or outside the circle, just not on the circle. 1, 1? Sure. 1, 1 is located, that's supposed to be a different color. Now it looks like the Death Star. That's okay. 1, 1 is inside the circle. What that means is if I put in 1 in for x and 1 in for y, you're asking yourself, is this true or false? False. 1 squared plus 1 squared is not greater than or equal to 9. So your third step talks about whether it's true or false. If it's false, you shade the other part of the graph. So since we picked a point that it was inside the circle and it made it false, that means everything outside of the circle would make it true. So your third step is always shade true. Now, not to turn this into an art class or anything, you don't want to go crazy with your shading here, because when we're all said and done, we're trying to figure out where these two shaded regions overlap. So if you try to shade it all solid the problem with that is you may not see where your final answer is. So colored pencils or cross-hatching like I'm doing would be a little bit more preferred. So basically that inequality is saying that any point that's on the circle or outside of the circle is true. Flash on. All right. Second one. Pick a color, any color except for purple or the blues. I heard red. Red works. We're now going to graph the equation x plus y equals 2. What does x plus y equal 2 look like? A line. What's the x-intercept of that line? 2. What's the y-intercept of that line? 2. Solid or dotted when we connect these 2 points? Solid. Oh. That's okay. Okay. Pick a point, any point that's clearly not on the line. Could we have picked 0, 0 this time? No. I'm sorry. I meant to say 1, 1. Darn it. Could we have picked 1, 1 this time? Now say no. Because 1, 1 is on this line. But could we have picked 0, 0? Sorry about that. Yeah, let's pick 0, 0. If we put in 0 in for x, oh, there's no x one up there. Sorry about that. I'll put a smiley face. 0 and for y? Is 0 plus 0 greater than or equal to 2? No. 0, 0 is below the red line. 0, 0 made it false. So where do we shade in reference to the red line? Above the right-hand side. So we're shading every point that is above this red line. Your final answer is where both regions overlap, so where the orange and the purple overlap. So if you want, shade, if you would, please shade at the darkest. I'm going to use a highlighter. I haven't used a highlighter, I think, all semester. Highlighter! Go around the horn here. Nice. That's good. Is there a light that comes in? Oh, my God. Oh, that's amazing. That's fun. All right. So any point in this region satisfies both inequalities.